Hello my dear students. So I'm going to continue with the lesson. In the previous chapters, you all can remember, first we discussed the difference between physical changes and chemical changes. So you all know in chemical changes, from the existing substances, those are the reactants, new substances are formed, that is the products. So their reactants get converted to products. That is a chemical reaction. And this chemical reaction can take place in 4 different ways. Those are the 4 types of reactions. Can you all remember those? The chemical combination reaction, chemical decomposition reaction, the single displacement reaction, and the double displacement reaction. Then you saw how we can identify these different types of reactions, and also when a reaction, a chemical reaction, a chemical change takes place, there are different observations like the evolving or liberation of gas bubbles, formation of precipitates, color changes, change in temperature, all those or any of those can accompany a chemical reaction. So with all those understand, now we will try to learn how we write chemical equations. So before we go into chemical equations, students, you're familiar with chemical formulae. Now you're familiar with the symbols of elements. You all know for different elements we use different symbols to identify them. And using those different symbols as well as their valencies, you know to write the chemical formula for each compound. So here when we write chemical equations, we will be using the chemical formulae of substances. Either the chemical symbols, symbols for elements, or chemical formulae for compounds. So there again, we can write equations, chemical equations in 2 ways. One is the word equation. You are familiar with that to a certain extent. Now say when we say magnesium reacts with oxygen, you can write magnesium plus oxygen giving rise to magnesium oxide. You can write that in words. But the information that we get from that particular equation is not much. So the best way of representing a chemical reaction is a balanced chemical equation. So with that in mind, we will start the chapter. Chemical equations. A chemical equation is the symbolic representation of a chemical reaction using chemical formulae. So here, that is the symbolic representation of a chemical reaction using chemical formulae. So when we start this part of the lesson, you should be very familiar with writing chemical formulae. So I will just go through writing chemical formulae. If you can remember, students, if it is a compound formed between sodium and oxygen, what do? You just need to know the valencies. Sodium has valency 1, oxygen valency 2. Then what do? We interchange the valencies. So you get the chemical formulae as Na2O1. But since this is 1, when you write the atom itself, it represents the presence of an atom of an element. So therefore, we don't need to write the 1. We write it as Na2O. At the same time, if you have magnesium and oxygen, magnesium belongs to group 2, oxygen group 6. So the valencies are 2 and 2. So you exchange the valencies, you get the formula as Mg2O2. Here again, because the two values, both the values are same, you don't need to write them. So here we write the chemical formula as MgO. So that represents sodium oxide, that is magnesium oxide. The same way, you are familiar with radicals also, molecular ions or polyatomic ions, radicals. For example, NH4 plus and chlorine. Now NH4 plus, the plus charge is the valency. So valency of ammonium ion is 1, chlorine is also 1. There we exchange the valency, you get the formula as NH4Cl. So like this, you are familiar with writing chemical formulae. So before we start writing equations, you should be very familiar with this part of the lesson that we learned before, writing chemical formulae. So then, if we look at chemical reactions, now in a chemical reaction, you all know students, there can be two or more or even one or more than one reactants. From that, we can get two or one or more than one products. For example, if we take magnesium and oxygen, two reactants give rise to magnesium oxide. We have seen that reaction before. So that is two reactants and one product. The same way, if you take calcium carbonate, if you heat it for a high temperature, calcium carbonate decomposes. So there you have one reactant, calcium carbonate decomposes into calcium oxide and carbon dioxide, two products. So you can have one reactant and more products, more than one reactants, one product, or on both sides you can have two or more reactants and two or more products. So you are familiar with all these examples when we wrote the different types of reactions. You have seen all these. So then, when writing chemical equations in the standard form, you have to remember this. So this is a standard way of writing the chemical equation. Reactants are written on the left hand side. So here this is the left hand side, that's the right hand side. We start with the reactants. So here students, we have a reactant. Then if we have one or more than one reactant, so here I will consider two reactants. So reactant and another reactant. Now these reactants are separated or shown in the equation separated by a plus mark. So we have to put a plus here. Say magnesium, oxygen. Magnesium is one reactant, oxygen is another reactant. Then from these reactants we get the products. So the products on the right hand side. And here we have the products. Again, if there are more than one product, we separate them by a positive sign, plus sign, and another product. So reactants going to products is the reaction. So we show this change using an arrow. So here we put an arrow. An arrow indicates the direction of a reaction. So you have the reactants on the left hand side, one or more reactants. You have the products on the right hand side, again one or more products, and the direction of the reaction from the reactants to the product is shown by the arrow. That is how the reaction takes place, or that is how the reaction is represented by the standard form. That is the chemical equation. In such instances, placing a plus mark, addition mark between them is the accepted way. Moreover, the reacting substances as well as the substances produced are indicated by their chemical symbols and formulae. So, chemical symbols if they are elements and chemical formulae if they are compounds. To write a chemical equation correctly, one should know chemical symbols and formulae as well. So, here I have already shown you all how to write chemical formulae, just to recall what you have already learned. So, you should be familiar with chemical symbols and the chemical formulae. Is that clear to you all? So, this is just the representation of a reaction. So, when we write chemical equations for each reaction, you should use the symbol or the relevant formula for the reactants and the products. Write the reactants on the left hand side, separate them by a plus sign, then use an arrow to indicate the direction of the reaction, and the products again are separated by a plus sign. So keeping this in mind, we will write some chemical equations and also we will learn to balance them. So let us write chemical equations. The example given to you, magnesium plus oxygen, magnesium oxide. You have seen this reaction, students. You take the strip of magnesium, you hold it to the Bunsen flame. Then you see it burning with bright white flame. And finally, what is the product or what remains? A white color powder or white color residue. What is that? That is magnesium oxide. So, magnesium reacts with oxygen in air and forms magnesium oxide. So, when we write this, now this is the word equation. For normally reactions, you can write a word equation. Word equation. In a word equation, students, you only write the reactants and products. We don't indicate the number of atoms present in each of them. Here when we write magnesium, it is actually the magnesium metal. So how do we write the magnesium metal? Using its chemical symbol Mg, and it exists as Mg naturally. The magnesium strip is only a magnesium metal. Whereas oxygen, now you have to use the plus sign. Oxygen exists as a diatomic gas. You all can remember that. Oxygen belongs to group 6. It's a diatomic gas. It's present as O2 molecules in air. So we have to write it as O2. Now here you can see we get more information than writing the word equation. Then we need to use the arrow to show the reaction, and here this is going to be magnesium oxide, MgO. So to write this chemical formula, you should know the valencies of elements. So Mg plus O2, you get magnesium oxide. Then students, when there is a reaction taking place, a chemical reaction taking place, you're familiar with the law of conservation of mass. That means we cannot create or destroy atoms of elements. So if we take magnesium, if we take a certain amount of magnesium, that will be converted to some other form, but it cannot be destroyed. The same way, you take a certain amount of oxygen, that will react with magnesium and will be present in oxygen. That is the meaning of law of conservation of mass. So if I read this, according to the law of conservation of mass, you have learned atoms are neither created nor destroyed. So that's important. Atoms are neither created nor destroyed during a reaction. You cannot create or destroy atoms. So the number of atoms of the respective elements in the reactants should be equal to their number of atoms in the products. So the number of atoms that are present on this side, left side, that is the reactants, for each element should be equal to the number of atoms of each element present on the other side. That's the product side, right hand side. Equating the number of atoms of reactants with those of the products is known as balancing the equation. So this is very important, students. You have to remember this. Always the number of atoms on the left side should be equal to the number of atoms on the right side for each element. So let's check. Now look at magnesium. Magnesium, there is one atom on the left hand side, reactant side. Product MgO has again one magnesium. So then of course the number of magnesium atoms are same. No problem there. But if you take oxygen, now here it's O2 gas. O2 means there are two atoms of oxygen in one molecule. But if you take magnesium oxide, there is only one oxygen. So is it balanced? Two oxygen atoms on the reactant side, only one oxygen atom on the product side. So it's not balanced. So we need to balance it. So how do we do that? This is a method that is known as the inspection method. I will discuss this in more detail again as well. So in an inspection method, you inspect the reactants and products. You look at the reactants and products, you look at their number and you balance the equation. So here, now we have magnesium plus O2 giving rise to magnesium oxide. Magnesium is balanced. Now when you have O2 there, you need to have two oxygens on the other side. Now let's say for magnesium oxide, since we need two oxygens, if we put 2 here, that is wrong. Why? Because you all know for a particular compound, there is a fixed number of atoms of each element that combine together to form a compound. So if it is magnesium oxide, one magnesium combines with one oxygen. So this is wrong. You can't write it as a subscript. So here you are changing the formulae of the compound. So that's wrong. So what we do is we need to put that 2 in front of this. So when you write a number in front of a compound or an element, now if you write a 2 in front of magnesium, that means there are 2 magnesium atoms. The same way, if you write a 2 in front of magnesium oxide, that means there are 2 molecules of magnesium oxide. Now if you count the number, there are 2 oxygen atoms, but there are 2 magnesium oxide molecules. Each molecule has 1 oxygen. So therefore, there are 2 oxygen atoms. So the oxygen is balanced. But if you look at the full equation again, earlier we had 1 magnesium and 1 magnesium, but now we have 1 magnesium in the reactant, but we have 2 magnesium atoms. Why we have written 2 in front? 2 magnesium atoms with the product. So what do we need to do? We need to balance that as well. So to balance that, we need to put a 2 here. So now if we check 2 Mg, we have 2 MgO. So there are 2 magnesium atoms. O2, 2 oxygen atoms. 2 MgO, again 2 oxygen atoms. Now if you look at the reactants and products, we have equal number of atoms of each element on the reactant side as well as the product side. So this is the balanced chemical equation for the reaction of forming magnesium oxide from magnesium and oxygen. 2 Mg, that's how we read the equation. 2 Mg or 2 magnesium plus O2 oxygen gas, that is O2, gives rise to 2 MgO. Is that clear, students? So like this, we can write many chemical reactions. I will again go through this reaction, how to balance it using the inspection method. And then thereafter we will do some more examples. There are 2 oxygen atoms in the reactants. Products contain 1 oxygen atom. So we wrote the equation first. What was the equation? We wrote the equation as Mg plus O2 giving rise to MgO. The same explanation, students. There are 2 oxygen atoms in the reactants. Products contain 1 oxygen atom. So you can see, students, there are 2 oxygen atoms in the reactants and only 1 oxygen atom in the product. So that is the first equation we wrote. So to balance oxygen, magnesium oxide cannot be written as MgO2. I explained this to you. You cannot write it as MgO2 because the formula of magnesium oxide produced by the above reaction is MgO. That's very important. You cannot change the chemical formula of a particular compound. Therefore, 2 is written in front of magnesium oxide. So, what did we do? We had magnesium plus O2 gas giving rise to 2MgO. We write the 2 in front of magnesium oxide. Then what did we do? When writing 2MgO, 2 magnesium atoms are present in the products. So now there are 2 magnesium atoms in the products. But there is only 1 magnesium atom on the reactant side. So 2 should come in front of magnesium. So here there is only 1 magnesium. There are 2 magnesium atoms. So what did we do? We had the reaction like this. MgO2 to MgO. That is this reaction. So in order to balance magnesium, we write a 2 in front. Now if you check, this is the balanced chemical equation of the reaction between magnesium and oxygen. The term balanced chemical equation. You have to remember that, student. So when they tell you to write the balanced chemical equation, you don't have to write it step by step. You have to directly write this equation. In the sense, you write the reactants, you write the products, use the arrow to show the direction of the reaction, and then you balance the reaction itself. You don't have to do it in steps like this. You only show one balanced chemical equation. Is that clear to you? So now let's look at some more examples. Study carefully how the balanced chemical equation is written for the following reaction also. What is the reaction? Reaction is given to you here. Aluminium metal reacts with dilute hydrochloric acid forming aluminium chloride and hydrogen. So what is the chemical formula for the substances there? Reactants and products. So what do we need to do? We have aluminium. We need to have dilute hydrochloric acid, that is HCl, and forming aluminium chloride, that is AlCl3. Why? Aluminium belongs to group 3, chlorine belongs to group 7, so valency 1. When you exchange, you get the chemical formula AlCl3. And hydrogen again is H2 gas, hydrogen gas. Write the formulae of the reactants and products correctly on either side of the arrow. So the reactants are aluminium. You use a plus sign. So after the plus sign, we need to write the dilute hydrochloric acid. So there, since we are writing the balanced chemical equation, we can just write the chemical symbol, chemical formulae. So here HCl. And the products, aluminium chloride and hydrogen gas. So aluminium reacts with dilute hydrochloric acid, giving rise to aluminium chloride and H2. Now check the number of atoms of each element present on either side of the arrow. Aluminium, there's only one atom. Here again there is one aluminium. So that is balanced. Take hydrogen. There is one hydrogen. There are two hydrogen atoms. Why H2? So it's not balanced. The same way, if we look at chlorine, one chlorine atom, but here we have AlCl3. So 3 chlorine atoms. So that is also not balanced. But if you look at the values, now one hydrogen, one chlorine, but here you have 3 chlorines and 2 hydrogens. Now to balance 3 and 2 with this. You need to have 3 chlorines, 2 hydrogens. Then what do? We consider the least common multiple. Least common multiple, LCM, is equal to 2 into 3, 6. So that is the value that we need to consider. 3 chlorine atoms and 2 hydrogen atoms are present in the products. Since the least common multiple of 2 and 3 is 6, write 6 as the coefficient of hydrochloric acid. So you need to put a 6 in front of hydrochloric acid. If I rewrite that equation like we did before, Al plus 6 HCl giving rise to AlCl3 plus H2. Now, is it balanced? You have 1 aluminium, correct. Now 6 HCl, that means 6 hydrogens and 6 chlorine atoms. But here we have only 3 chlorine atoms. So what do? We need to make it 6. To do that, we need to multiply by 2. That means you write the coefficient 2 in front of AlCl3. 2 into 3 chlorines. So there are 2 molecules of aluminium chloride. 1 molecule has 3 chlorines. So 2 molecules have 2 into 3, 6 chloride ions or 6 chlorine atoms there. Here there are 6 chlorine atoms. There are 6 chlorine atoms. The same way, if you look at hydrogen, there are 6 hydrogen atoms. Here you can see H2. So there are only 2 hydrogen atoms. To make it 6, what do? We write 3 in front here. 3H2. So there are 6 hydrogen atoms. Is that clear to you all? Now again look at the reaction. Aluminium, 6 hydrochloric acid, 2 aluminium chloride, 3H2. Again, if you look at the number of atoms of aluminium, there is 1 here, now there are 2. So what do we need to do? We need to get this changed. So we need to write a coefficient 2 in front of aluminium. So 2 aluminium plus 6 hydrochloric acid will give rise to 2 AlCl3 plus 3H2. That is the balanced chemical equation. You can check it again. 2 aluminium atoms, 2 aluminium atoms. 6 hydrogen atoms. Here you can see 3H2, so 6 hydrogen atoms. 6 chlorine atoms. Here again you have 2 into 3, 6 chlorine atoms. So the number of atoms on the left hand side is equal to the number of atoms of each element on the right hand side. So now we have the balanced chemical equation for the reaction of aluminium with hydrochloric acid. You all have to remember that. This is the way of balancing chemical equations. So that is the balanced chemical equation for the reaction of aluminium with hydrochloric acid. I am sure you all can understand that clearly. So I will move on to the next slide, students. So again, the continuation from what I discussed, the same thing. Now there are 6 hydrogen atoms in the products. So write 3 as the coefficient of H2. As there are 6 chlorine atoms in the reactants, insert 2 as the coefficient of AlCl3. That we did. So here what did we do? We had aluminium and then we had HCl, we had AlCl3 and we had H2. So since we had 6 hydrogen atoms, we put a 3 there. So here we had 6 HCl. So to balance that, we put a 3 there. Then what did we do? Because we had 6 chlorine atoms, we had to put 2 there, 2 AlCl3. So again, to balance the 2 aluminium atoms on the product side, what did we do here? We have to put a 2 in front of aluminium. So there are 2 aluminium atoms in the reactant. Students, there is a mistake in the printing. This should be products. So here we already have 2 aluminium atoms in the products. Hence write 2 as the coefficient of aluminium. That is with the reactants. So we write the 2 there. So this is what I explained before also. So from that we get the balanced chemical equation. So what is the balanced chemical equation? Again, to do it together, normally when you are asked to write a balanced chemical equation, this is how we write. We write the reactants, aluminium plus HCl, the 2 reactants, giving rise to aluminium chloride plus H2 as the products. So then what did we do? In order to balance the chlorine, 3 chlorines and hydrogens, we put the least common multiple 6 in front there. So 6 HCl. Then to balance those, we put a 2 in front of AlCl3, 3 in front of H2. And then to balance aluminium, we put the 2 there. So you have the balanced chemical equation. Here students, I have done the same examples. I have explained it 3 times. So here, this is the balanced chemical equation for the reaction. 2Al plus 6HCl giving rise to 2AlCl3 and 3H2. I'm sure you all can understand that. So with that, we will move on to the next slide. The method of balancing chemical equations as described above is known as the inspection method. I told you all this. You look at the substances and you balance them. So that is known as the inspection method. You inspect the reactants and products and you balance it. So balance the following equations by using the above method. That is the inspection method. So if you look at the first reaction, Na, that is sodium, plus O2, oxygen, giving rise to Na2O, sodium oxide. So sodium plus oxygen giving rise to sodium oxide. If you balance that equation, I will write it again here. You have sodium plus oxygen giving rise to Na2O. Now look at the reactants. 1 sodium atom, there are 2 sodium atoms in the product. Why? Na2O. When you take oxygen, O2. So 2 atoms of oxygens on the reactant side, but only 1 oxygen atom on the product side. You can either balance sodium first or oxygen first, but it is easier if we start with oxygen. So O2, there are 2 atoms. To balance that, can you put the 2 here? No. That will change the chemical formula. So you can't do that. So what do? We write it as a coefficient 2 there. So now 2 Na2O, 2 sodium oxide molecules. Now if we count the number of oxygen, O2, 2 oxygen atoms, 2 Na2O, again 2 oxygen atoms. So that is balanced. But as you can see, there is only 1 sodium here, but there are 2 Na2O molecules. In 1 sodium oxide, Na2O, there are 2 sodium atoms. If you take just 1 molecule, there are 2 sodium atoms. We have 2 such molecules. So there are 4 sodium atoms. Then we need to write the coefficient 4 in front of sodium. 4 sodium plus O2 giving rise to 2 Na2O. That is the balanced chemical equation for the reaction of sodium with oxygen, producing sodium oxide. I am sure that is clear to you all. You can identify this reaction also, students. There are two reactants, sodium and oxygen, giving rise to one product. So, it is a chemical combination reaction. And this is the balanced chemical equation of the chemical combination reaction taking place between sodium and oxygen, giving rise to sodium oxide. Is that clear to you all? Then the next one. Second one, aluminium plus oxygen giving rise to Al2O3, aluminium oxide. So, aluminium plus oxygen giving rise to Al2O3. Again, you can see that, students. Now, there is one aluminium, Al2, two aluminium atoms. O2, two oxygen atoms. Al2O3, so 3 oxygen atoms. Again, the two values, 2 and 3. So, you have 2 oxygen atoms here. You have 3 oxygen atoms there. So, again, least common multiple, you can have 6 oxygen atoms on either side. It's easy to balance. So, to make this 6, what can we do? O2, if you had 3 O2 molecules, there will be 6 oxygen atoms. So, we put a 3 in front of O2, 3 O2. So, to make this also 6, you have 3 oxygen atoms. If we put a 2 in front, 2 into O3, there are 6 oxygen atoms. Now, the oxygen atoms are balanced. How about aluminium? We have 2 Al2O3. Already we have Al2, 2 aluminium atoms in one molecule. We have 2 such molecules. So, there are 4 aluminium atoms in the product side. So, we need to use the coefficient 4. 4 aluminium plus 3 O2 gives rise to 2 Al2O3. That is the balanced chemical equation for the reaction of aluminium with oxygen forming aluminium oxide. Here also, students, you can identify the reaction. It is a chemical combination reaction. Then the next one. We have another reaction. N2, nitrogen gas, H2 hydrogen gas, reacting and forming NH3, ammonia gas. Nitrogen reacts with hydrogen and forms ammonia gas. Again, a chemical combination reaction. So, if we need to balance that, N2 gas plus H2 gas gives rise to NH3. You can see that also. Now, N2, there are 2 nitrogen atoms. H2, there are 2 hydrogen atoms. But on this side, there is only one nitrogen, NH3, only one nitrogen, but there are 3 hydrogen atoms. So, if we balance the hydrogen atoms first, it will be easy for us. Now, H2, H3. Now, you all are familiar with this. 2 and 3. So, we need to make it 6. How do we do that? We write a 3 in front there. 3 into 2, 6 hydrogen atoms. Again, H3. So, you need to have 2 ammonia molecules. 2 into 3, 6 hydrogen atoms. Is that okay? So, hydrogens are balanced. 3H2, so 6 hydrogen atoms. 2NH3, 6 hydrogen atoms. Now, check the number of nitrogen atoms. N2, 2 nitrogen atoms. 2NH3, again 2 nitrogen atoms. So, that is also balanced. N2 plus 3H2 giving rise to 2NH3. 1 nitrogen molecule, 3 hydrogen molecules giving rise to 2 ammonia molecules. Is that clear? So that is the balanced chemical equation. Then the next one. What is this? H2 hydrogen gas, O2 oxygen gas, H2O water. So the reaction of hydrogen with oxygen to form water. Again a chemical combination reaction. So if we need to balance that chemical combination reaction, how do we do that? We write the reaction again, H2 plus O2 giving rise to H2O. Now check the number of atoms. H2 means 2 hydrogens. H2O again H2, there are 2 hydrogen atoms. So that is balanced. But if you take oxygen, O2, 2 oxygen atoms, H2O has only 1 oxygen atom. So we need to balance that. How do we do that? We have 2 oxygen atoms here, we have only 1 here. So do we write the 2 there? No. Why? If we write the 2 there, we will be changing the chemical formula of water. That's not correct. That's incorrect. So we have to write it as a coefficient in front. 2 water molecules. 2 H2O. So now oxygen is balanced. But what have we done? We have increased the number of hydrogen atoms. 2 into 2 H2O. So 2 into 2, there are 4 hydrogen atoms. So again, we need to make this into 4 hydrogen atoms. How is that done? Write the coefficient 2 in front. 2 H2. So 2 into 2, there are 4 hydrogen atoms. So 2 H2 plus O2 gives rise to 2 H2O. Hydrogen with oxygen forming water. So now also you can see, students, if we just write it in words, we will be writing as hydrogen, oxygen, water. It will not give us much information. I mentioned that to you all before also. If you just write this equation also, we don't get proper information. But once we balance it like that, you can see how many hydrogen molecules are needed to react with oxygen to give rise to water. And also you can see how many water are formed. So that is why we need to balance the chemical equations. Is that clear to you all? Then there is one more. KClO3, potassium chlorate. This is potassium chlorate. Potassium chlorate. Giving rise to KCl, potassium chloride, and oxygen. So that is the Bird equation. Potassium chlorate giving rise to potassium chloride and oxygen. Now this reaction is different from the above reactions. What type of a reaction is this? Only one reactant giving rise to 2 products. So you all know it is a chemical decomposition reaction. So when potassium chlorate decomposes, it gives rise to potassium chloride and oxygen. Now we need to balance this. KClO3, potassium chlorate, gives rise to KCl, potassium chloride, and O2. Now look at the number of atoms in the compounds, the reactants and the products. So here we have potassium chlorate giving rise to potassium chloride and oxygen. Now look at the number of atoms on either side of the arrow. Reactants, 1 potassium on the product side. That's balanced. Chlorine, Cl, 1 Cl, and KCl, again 1 Cl. So the chlorine atoms are also balanced. How about oxygen? O3. So there are 3 oxygen atoms. Here this is O2, only 2 oxygen atoms. Then what do we need to consider? We need to have a total of 6 oxygen atoms, 2 and 3. To balance that, we consider the least common multiple, 6. So there needs to be 6 oxygen atoms. How can we do that? We need to multiply this by 2. So if we write a coefficient in front of potassium chlorate, that means 2 into 3, there are 6 oxygen atoms on the reactant side. Then we need to put 3 as the coefficient there. 3 into 2, there are 6 oxygen atoms on the product side. So that of course is balanced. Number of oxygen atoms on the reactant side and the product side are 6. It's balanced. But we changed potassium chlorate. So now there are 2 potassium atoms. There are 2 chlorine atoms. So what do we need to do now? We need to put a coefficient in front of potassium chloride. So if we write the 2 there, now 2 potassium, 2 chlorine atoms. Here also 2 potassium, 2 chlorines. Here also 2 potassium, 2 chlorines. So now the reaction is balanced. So the balanced chemical equation for the chemical decomposition of potassium chlorate to form potassium chloride and oxygen is written like this. 2 KClO3 gives rise to 2 KCl plus 3 O2. That is how you balance the reactions. So I am sure students, after doing so many examples, now it should be very clear to you how you balance the chemical equation. And here this is known as inspection method because you look at the atoms of each element on the reactant side and the product side and then you balance them. So these are the balanced equations for all the given reactions. Is that clear to you all? So with that, I will move on to the next slide. So you have this assignment given in your textbook, assignment 16.1. Consider the word equations from 1 to 5 given below. So you need to consider the word equations and then write the balanced chemical equations for the word equations given. State to which type of reactions do those word equations belong. So you need to identify the type of reaction as well. I did that for you all in the previous slide as well. We identified what type of reactions they are and then we balance the reactions. So let's look at the reactions. First one, so the first one, A, you have magnesium. I will write it again so it's easy for us to balance, plus oxygen, giving rise to magnesium oxide. You are familiar with this reaction. What is magnesium? Mg, the symbol of the element. Then we need to have oxygen, O2, giving rise to the compound magnesium oxide. So that is MgO. Now what do we do? Look at the number of atoms on either side, reactant side and the product side. Magnesium 1 atom, here also magnesium 1 atom. O2, how many atoms? 2 oxygen atoms. MgO, how many oxygen atoms? Only 1. So what do? We need to put a coefficient. You don't put it as a subscript. You have to put a coefficient. What is the number? we need to get 2 oxygen atoms. So you need to put a 2 in front of MgO. Then what? There are 2 oxygen atoms. It's balanced with O2 here. But there are 2 Mg atoms. Here there is only 1 Mg atom. So then here there is only 1 magnesium atom. What do we do there? We need to put a coefficient 2 in front of Mg. So 2 Mg plus O2 gives rise to 2 MgO. That is the balanced chemical equation. 2 magnesium, oxygen giving rise to 2 magnesium oxide. What type of reaction is this? It is a chemical combination reaction. So this is a chemical combination reaction. How do you identify a chemical combination reaction? There are 2 reactants combining together to form only one product. A plus B giving rise to C. You can remember the common equation. So this is a chemical combination reaction. Magnesium, oxygen giving rise to magnesium oxide. Then we have the second reaction. What is it? Zinc and copper sulfate giving rise to zinc sulfate and copper. So B, zinc plus copper sulfate you all know these students, when there are 2 parts of the name, you need to have a space in between. Copper sulfate giving rise to zinc sulfate plus copper. So, now we need to write the balanced equation. To do that, you need to know the chemical formulae of the compounds and the symbols of the elements. So, you know for zinc, Zn plus copper sulfate, CuSO4 giving rise to zinc sulfate, ZnSO4 plus copper Cu. Copper, the valency is 2. Sulfate, SO4 2 minus. So the formula is CuSO4. The same way, zinc valency 2, sulfate SO4 2 minus. So zinc sulfate is ZnSO4. These elements, copper, zinc, iron, these are not part of the first 20 elements of the periodic table. But students, you all have to know the chemical formulae. You need to remember the valencies and you need to know the chemical formulae of some of these compounds. Copper sulfate CuSO4, zinc sulfate ZnSO4. Now look at the reaction. 1 zinc atom. In zinc sulfate also there is 1 zinc atom. Then in copper sulfate there is 1 copper. Here there is 1 copper in the product. Then here you can take sulfate as a whole or you can look at each atom separately, atom of each element separately. Sulfur, there is 1 S, 1 sulfur. Here again 1 sulfate, so there is only 1 sulfur. Same way, oxygen, there are 4 oxygen atoms, O4. So 4 oxygen atoms. Here also O4. So that is also 4 oxygen atoms. The reaction is already balanced. The atoms of the elements on the reactant side are equal to the atoms of each element on the product side. So it's already balanced. This is the balanced chemical equation of the reaction between zinc and copper sulfate, giving rise to zinc sulfate and copper. Now there is 1 element, 1 compound giving rise to 1 compound and another element. You can see zinc has displaced what? Copper. So this is a single displacement reaction. You can identify this as single displacement reaction. How did you identify that? Now zinc is here, copper is here. Zinc displaces copper from its compound in a solution. So it has become zinc sulfate and you know copper will deposit. We have seen this type of reaction also. So with that students, I will move on to the next question. I am sure you were also able to balance these two equations and you were able to identify them correctly. The next one, second question, A part 2A, magnesium plus hydrochloric. You all know it has to be hydrochloric acid. Again, there's a printing mistake, students. It should be acid. Hydrochloric acid giving rise to hydrogen plus magnesium chloride. So what do we need to do? We need to write the symbols or the chemical formulae for the reactants and products. So magnesium symbol Mg, hydrochloric acid, what is it? HCl, you are familiar with that. HCl gives rise to hydrogen, that is H2. When they say hydrogen, you should know that it is H2 gas. So H2 and magnesium chloride. Magnesium chloride is MgCl2. Magnesium valency 2, chlorine valency 1. So when you exchange and write the formula, you get it as MgCl2. So then, now look at the atoms. Mg1, Mg1, correct. H1 but H2. Same way Cl1, here there are 2 chlorine atoms. So both H and Cl have to become 2. So what do? We write the coefficient in front, 2HCl and check. Again, Mg same, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. So it is balanced. 1 Mg plus 2 HCl giving rise to H2 plus 1 MgCl2. You don't have to write the 1 here. That's already there. So what type of a reaction is this? Again, look at the reaction. Element, compound, giving rise to an element and a compound. Here we had HCl, but magnesium displaces HCl. That is why H2 is evolved and magnesium has displaced HCl. MgCl2 is formed. So there is only one displacement, A plus BC giving rise to AC plus B. So that is a single displacement reaction. Single displacement reaction. Then we have the next one. The B part, ferrous sulfate plus we have sodium hydroxide, giving rise to ferrous hydroxide and sodium sulfate. So you can see ferrous sulfate, sodium hydroxide. Now it has become ferrous hydroxide. Ferrous has displaced sodium combined with hydroxide. Then you have sodium sulfate. Sodium has displaced ferrous and combined with sulfate. So you all know this has to be a double displacement reaction. Ferrous sulfate, sodium hydroxide giving rise to ferrous hydroxide and sodium sulfate. Now we need to write the balanced chemical equation. To do that, you need to write the chemical formula. So here students, before I go to that, you have to remember, now iron, when it has a valency 2, the iron becomes Fe2 plus, and that is called ferrous iron. So when this iron is present in a compound, we call it as ferrous. Ferrous sulfate means there is Fe2 plus, that is ferrous iron. You have to remember that valency as well. Like I told you all, zinc, copper, valency 2, ferrous also has valency 2. So now, ferrous sulfate, so FeSO4, Fe2 plus, SO4, 2 minus. So that is the chemical formula. You have to know that. Then for sodium hydroxide, you know, NaOH. H gives rise to ferrous hydroxide. So FeOH, this has valency 2, OH is minus. So when you exchange, it should be Fe1 and OH has to be twice. FeOH twice is ferrous hydroxide. And sodium sulfate, Na2SO4. Sodium valency 1, sulfate SO4 2 minus. So you get the formula as Na2SO4. Now look at the atoms. Fe, 1 atom. 1 Fe there. So no problem. Sulfur, 1 sulfur. There 1 sulfur in sodium sulfate. Oxygen, there are 4 oxygen atoms here. But in sulfate, as a whole if you take, here there are again 4 atoms. So that is sulfate. That is also balanced. But if you look at the total number of oxygen atoms, there is an oxygen here as well. So you need to consider all the atoms. So 4 here, 1 here. But here already we have those 4 oxygen atoms. We can just leave that aside. So here you can see students, FeOH twice. So 2 oxygens, 2 hydrogens. The same way, if you look at sodium. Now there's only 1 sodium here. But if you look at this, sodium sulfate, Na2, there are 2 sodium atoms. So you need to have 2 oxygens, 2 hydrogens and 2 sodium. So easy. What do? We put a coefficient 2 in front of sodium hydroxide. 2 in front of sodium hydroxide. So now check. 2 sodium atom, 2 sodium atoms. 2 oxygens, that is apart from SO4. We have already seen that is balanced. So in addition, we have 2 oxygen atoms here, 2 oxygen atoms there, 2 hydrogen atoms here, 2 hydrogen atoms there. So now it is balanced. FeSO4 plus 2NaOH giving rise to FeOH twice and sodium sulfate. Is that clear to you all? So then, what type of a reaction is this? We have already identified. Double displacement reaction. Double displacement reaction. Double displacement reaction. Is that clear, students? Double displacement reaction. So then I'll move on to the next one. Third one, A, calcium carbonate. When you heat, you get calcium oxide and carbon dioxide. You're familiar with this reaction. This is a chemical decomposition reaction. 3A, calcium carbonate. When you heat, you get calcium oxide and carbon dioxide. Chemical decomposition reaction. You all know calcium carbonate, CaCO3. So you have to provide heat. You can write it as heat, or we can use this symbol to represent heat. Both are okay here. The delta symbol like a triangle to represent heat. You get calcium oxide and carbon dioxide. Now we need to balance it. 1 calcium, 1 calcium. 1 carbon, 1 carbon. Oxygen, there are 3 oxygen atoms on the reactant and 1 plus 2 oxygen atoms here. So there are 3 oxygen atoms in the products. All the atoms are same on the reactant side and the product side. Atoms of each element is equal on the reactant side with the product side. So the equation is already balanced. Calcium carbonate on heating gives rise to calcium oxide and carbon dioxide. And it is a chemical decomposition reaction. Is that okay? I'm sure you also wrote this correctly. Then the next one, student. Now here we have iron and sulfur giving rise to iron sulfide. B part, iron plus sulfur giving rise to iron sulfide. So earlier students, you were introduced to the term ferrous sulfate. Here it says iron and sulfur giving rise to iron sulfide. Again, iron you know is Fe and the valency we used it Fe2 plus. So valency 2. So iron is Fe plus sulfur S giving rise to Fes, iron sulfide. So if you look at the atoms, Fe1, Fe1, sulfur 1, sulfur 1. So there's no need to balance. It's already balanced. What type of a reaction is this? 2 elements combine and form a compound. So it is a chemical combination reaction. Chemical combination reaction. Chemical combination reaction. Iron plus sulfur giving rise to iron sulfide, Fes. So with that, I will move on to the next one. Fourth one, calcium chloride. Calcium chloride plus sodium carbonate giving rise to sodium chloride plus calcium carbonate. So there are students, calcium chloride, sodium carbonate. So sodium displaces calcium and combines with chloride, so sodium chloride. Same way calcium displaces sodium and combines with carbonate. So calcium carbonate. There are two displacements. So it is a double displacement reaction. Now to write the balanced equation. Calcium chloride CaCl2 by the valency CaCl2 calcium chloride. Then sodium carbonate Na2CO3. Now I am sure you all know the correct chemical formulae for these compounds. So then you get sodium chloride NaCl plus calcium carbonate. Now let's check the number of atoms. One calcium here, there is one calcium there. There are two chlorine atoms, there is only one chlorine atom. There are two sodium atoms, there is only one sodium atom. Carbon, one carbon, one carbon. O3 and O3. So carbonate is also balanced. What needs to be balanced? You need to have two chlorines and two sodium atoms. So what can we do? We can write a coefficient of 2 in front of sodium chloride. Now it's balanced. Calcium and calcium balanced. Two chlorine atoms, two NaCl, so two chlorine atoms. Na2, two sodium atom, two NaCl, again two sodium atoms, balanced. Then carbonate, one carbon and three oxygens. One carbon and three oxygens. It's balanced. CaCl2 plus Na2CO3 giving rise to 2 NaCl plus CaCO3. And it is a double displacement reaction. Double displacement reaction. Double displacement reaction. Then we have the next one. Iron oxide plus carbon monoxide giving rise to iron and carbon dioxide. So B part, iron oxide plus carbon monoxide giving rise to, we had iron and carbon. Iron plus carbon dioxide. Now if we write the chemical formulae, iron oxide, FeO. We take the valency of iron as 2, FeO, plus carbon monoxide, CO, giving rise to iron, Fe, plus carbon dioxide, CO2. What do you think is happening here? So look at the reaction, students. FeO plus carbon monoxide, Fe plus carbon dioxide. Now you can see this oxygen has combined with carbon monoxide. So what has happened? Carbon monoxide has displaced iron. So carbon monoxide displaces iron, iron comes out and oxygen combines with carbon monoxide giving rise to carbon dioxide. So that has to be a single displacement reaction. So you all can understand that it is a single displacement reaction. So now we need to balance it. Check. Fe, one atom of Fe, there's one atom of Fe there. Oxygen 1 and 2. There are two oxygen atoms on the reactant side. CO2, there are two oxygen atoms on the product side. Then we have carbon, C, and one carbon there. So that is also balanced. So that means this reaction is balanced. This is a balanced chemical equation for the reaction of iron oxide with carbon monoxide giving rise to iron and carbon dioxide. So this is a single displacement reaction. Single displacement reaction. Single displacement reaction. So here students, iron oxide, we have considered the simple form of iron oxide, FeO. But remember, in the same lesson itself, we will be discussing extraction of iron. Then there we will be looking at different iron oxide, that is hematite. It is the mineral containing iron, hematite. There the chemical formula for iron oxide is different. It will be Fe3O4. And at that time, there is a reaction with carbon monoxide. The products again are iron and carbon dioxide. But the way we balance the equation will be different. Because the formula of the iron oxide there, that is hematite, is different. It will be Fe3O4. So when I come to that point, I will remind that to you all again. So when we take the chemical formula of iron oxide as FeO, we have this balanced chemical equation. You have to remember that, students. But the oxides of iron can vary depending on the compound. So as I told you, hematite is different. So there, the way we balance the reaction will be different. Is that clear to you? So with that, I will move on to the next slide. The last question, question number 5. 5A is going to be sodium plus oxygen giving rise to sodium oxide. So if we write the symbols and chemical formula, sodium Na, oxygen is O2, you know it's O2 gas, gives rise to Na2O, sodium oxide. What type of a reaction is this? Sodium combines with oxygen to form sodium oxide. Chemical combination. So now to balance, there's one sodium, there are two sodium atoms there. At the same time, there are two oxygen atoms here. There's only one oxygen atom there. I told you all before also, it's easier if you balance oxygen atom first. So O2, here there is only one O. So what do? We write a coefficient in front of Na2O. So there are two oxygen atoms balanced. But 2 into 2, Na2O, so 2 into 2 sodium, there are 4 sodium atoms. So to balance that, we put a coefficient 4 in front of sodium. So 4 sodium atoms combine with O2 molecule to give rise to 2 Na2O. Sodium with oxygen giving rise to sodium oxide. That is the balanced chemical equation for the reaction of sodium and oxygen chemically combining to form sodium oxide. So this is a chemical combination reaction. Chemical combination reaction. Chemical combination reaction. Then the next one. What is it? Water plus sodium giving rise to sodium hydroxide and hydrogen. So B part, water plus sodium giving rise to sodium hydroxide and hydrogen. So if we write the chemical formulae and the symbols, water H2O plus sodium Na gives rise to sodium hydroxide NaOH plus H2 hydrogen. Now to balance. H2, so 2 hydrogen atoms. NaOH, there is 1 hydrogen. H2, there are 2 hydrogens. So there are 3 hydrogen atoms there. Then oxygen, only 1. Oxygen, only 1. 1 sodium, 1 sodium. So we need to balance hydrogen. Now there are 2 hydrogens here. There are 3 hydrogens there. Normally you are used to balancing it by taking the least common multiple. But we don't have to do that here. What we can do is, if we put a coefficient 2 in front of NaOH, then what will happen? There will be 2 hydrogens and 2 hydrogens. There will be 4 hydrogens. The same way, if you put a 2 in front here, a 2H2O, there will be 4 hydrogens. So this is slightly different from what we have been doing. You put a 2 in front here and coefficient 2 in front of water. 2H2O, so 4 hydrogens. 2NaOH, 2 hydrogens plus 2 hydrogens, 4 hydrogens. Now we need to check oxygen. 2H2O, so 2 oxygen atoms, 2 oxygen atoms. That is also balanced. You have 1 sodium here, 2 sodium atoms there. So you can write, or you have to write 2 in front of sodium. So now of course all the atoms of each of the elements on the reactant side are equal to the atoms of each element on the product side. 2 4 hydrogens, 2 and 2 4 hydrogens. 2 oxygens, 2 oxygens. 2 sodium, 2 sodium. So this is the balanced chemical equation for the reaction between water and sodium, giving rise to sodium hydroxide and hydrogen. Now can you identify this reaction? Water has H2O. Now sodium is here. Here the product is NaOH. Now water, you can remember students. If you take water, OH, H. Now this part is OH, this is H. If you put sodium, sodium can displace this hydrogen. Sodium displaces hydrogen from water. That is why it combines with OH and forms NaOH, and hydrogen is evolved as or liberated as hydrogen gas. So what type of a reaction is this? Sodium displaces hydrogen from water. So it is a single displacement reaction. A single displacement reaction. Single displacement reaction. 2H2O plus 2Na giving rise to 2NaOH and H2. I am sure you all were also able to write all these equations and identify the reactions correctly. So with that, we have finished the exercise. I will move on to the next slide. When words are used to write a given chemical reaction, we face lot of difficulties. I have mentioned this before. Understand this through the following examples. Now look at these following examples. Given below is the reaction between hematite, here you can see hematite, and carbon monoxide. I told you all students, when we wrote the reaction between iron oxide and carbon monoxide, I told you all we will come across a similar reaction. This is the one. This is the reaction that we will be discussing again when we discuss extraction of iron. So this is hematite, Fe2O3. This is carbon monoxide, CO, gives rise to Fe, iron, and CO2, carbon dioxide. But look at the balanced equation. Since this is Fe2O3, we need to have 3 carbon monoxide molecules. So it's balanced. Then we have 2 Fe atoms. Then here we have 3 CO2 molecules. That is a balanced chemical equation. Fe2O3 plus 3CO gives rise to 2 Fe plus 3 CO2. If we write this as a word equation, you cannot get a lot of information. We will look at that now. So here, this is the reaction. Writing in words does not show the ratio of atoms of elements constituting compounds. So here we will be writing it as hematite plus carbon monoxide giving iron and carbon dioxide. So we won't know how many of each reactant and product are there. So we don't get that information. The ratio of atoms is not known. But when written as a chemical formulae, the ratio of elements in the compound can be definitely known. So here you can see 3 carbon monoxide, 2 Fe, 3 CO2 and 1 Fe2O3. All that is known to us. Then the equation can be balanced. Once the balanced equation is found, the ratio of masses of the respective elements or compounds that should be mixed to obtain the maximum amount of the products when performing the reaction practically can be calculated. This is important. Now here you can see, students, you need 1 Fe2O3 to react with 3 CO to produce 2 Fe and to release 3 CO2. That is the ratio. After the reaction is balanced, 1 Fe2O3, 3 CO gives rise to 2 Fe and 3 CO2. So if you take 1 mole of Fe2O3, that will react with 3 CO, that is 3 carbon monoxide moles, and give rise to 2 moles of Fe and 3 moles of carbon dioxide. That is the ratio. So accordingly, if you take 2 moles of Fe2O3, you will get 6 moles of carbon monoxide to react completely, and you will get 4 moles, double the number, 4 moles of iron and 6 moles of carbon dioxide. So if you use 10 moles of hematite, Fe2O3, you will need 30 moles of carbon monoxide, 20 moles of iron will be produced, and 30 moles of carbon dioxide will be liberated. So that is how we use this ratio. I am sure you all can understand that. So here you can see when we can practically calculate. So writing equations using chemical symbols and formulae not only makes the task easier but also helps calculation. So it helps to do the calculation properly. We will look at that in a little bit more detail in the next slide. So by the above equation written using the symbols and formulae, following information can be obtained. So here I will write the equation again, Fe2O3 plus 3 CO. We got 2 Fe plus 3 CO2. That was the reaction that was given in the previous slide. So by the above equation, that is this, written using the symbols and formulae, following information can be obtained knowing the relative atomic masses of the elements. So that is given to you there. The relative atomic mass of Fe is 56, oxygen 16, carbon 12. The relative molar masses can be obtained as Fe2O3 160 grams per mole. How do we calculate that? Fe2O3. So you have 2 molecules of 2 iron atoms. Each one is 56. Plus you have 3 oxygen atoms. Relative atomic mass of oxygen is 16. So 2 into 56, 112 plus 3 into 16, 48. So you get the value as 160. If it is molar mass, the unit is grams per mole. We have discussed this also in one of the previous lessons. So you all know that. That is how we get this Fe2O3 equals 160 grams per mole. So from that, the first one, 3 moles of carbon monoxide is required to react with 1 mole of hematite. I explained that to you all before. So here you have 1:3 ratio. So 1 mole of hematite, 3 moles of carbon dioxide. Hence, 28 into 3 grams of carbon monoxide. Carbon monoxide, carbon 12, oxygen 16. So when you add them together, the molar mass of carbon monoxide is 28. 28 into 3 moles. That is equal to 84 grams of carbon monoxide are required to react with 160 grams of hematite. Fe2O3, 160 grams, carbon monoxide, 84 grams. The same way, 2 moles of iron are formed in the above reaction. So, thus 56 into 2 grams. That is 112 grams of iron are formed in the above reaction. 3 moles of carbon dioxide are formed in the above reaction. So, therefore, 44 into 3, that is 132 grams of carbon dioxide are formed in the above reaction. Again, if we quickly summarize that, Fe2O3 plus 3 carbon monoxide gives rise to 2 Fe plus 3 CO2. So, if you take the ratio 1:3:2:3. So, 1 mole, 3 moles, 2 moles and 3 moles. So, we calculated molar mass as 160. So, if you take 160 grams of hematite, you need to have 28 into 3. That is 84 grams of carbon monoxide, and iron is 56 into 2. So, you will get 112 grams of iron, and also CO2, carbon 12 and oxygen 16 into 2. So, it's 12 plus 32, 44 grams per mole is CO2 into 3. So, that is going to be 132 grams. So, if you take 160 grams of hematite, you need 84 grams of carbon monoxide to completely react with it. During that reaction, 112 grams of iron will be produced and 132 grams of carbon dioxide will be released. So, as I told you all before, if you get 1600 grams, you can see it's 10 times more. You will need 840 grams, again 10 times more. You will get 120 grams, again 10 times more. And here you will get 1320 grams of carbon dioxide. So, since you know the mole ratio, you know the mass ratio, you can calculate it for any given value. Is that clear to you all? That is the advantage of having a balanced chemical equation. So, this is very useful in industrial productions, industrial processes, as well as in reactions carried out in the lab as well, in the laboratory as well. So, that is why you all need to learn the correct way of balancing chemical equations, and you have to have a good understanding. To do that, you need to know the chemical symbols as well as the chemical formulae of elements and compounds. I am sure with that explanation, you all know very well how to balance chemical equations. With that, students, I will end this chapter, and in the next chapter, we will look at reactions of metals.